So today we are looking at lesson 4-3, which is a review of factoring. And so I'm not going to go over every problem on here. So if you want to practice the problems that I don't go over, you can look at the notes that I have put online and try those and then check your answers from those notes that I put online. All right, so we're going to start with the first section, greatest common factor. So as you look at these, we're going to look at 2 and 4. So I'm going to make these bigger. The very first question you should always ask yourself is there a greatest common factor? And so with this one, 40 and 64, the biggest number that you can divide both of them by and divide by the same number is 8. And then as you look at the variables, you want to ask yourself, how many x's could I take the same amount away from both of them? So this one has 8 x's to give, this one has 4. So the most that I could take away from both of them and take the same amount would be 4 x's, because I can't take 8 x's from this one because it doesn't have enough to take. So the most I can take is just 4. So I'm going to take an x to the 4th out, and then I can take a y from each one and take the same amount as well. So out in front of your parentheses goes your greatest common factor, and then you're going to perform the division. So 40 divided by 8 is 5. And then for the x's, when you divide like bases, you subtract the exponents. So I am going to cancel all of these with 4 up top. So I end up with x to the 4th. And then the y's cancel 1 for 1. So that's it for the first term. Then for the second term, 64 divided by 8 is 8. And so that's a positive 8. And then the x to the 4ths cancel 1 for 1, and the y's cancel 1 for 1. So I really don't need my parentheses way out there, but since it won't let me erase it, it's going to be stuck there. So that's your final answer. You always want to make sure that you look inside the parentheses and make sure that you didn't miss anything, or that it's not factorable further, which in this case it's not. So then what I'd like you to do is to pause the video, and I want you to try number 4 on your own and see if you can take out the greatest common factor. All right, so as you look at the numbers, 3, 5, and 8, they do not have a number in common that you can divide them all by. So the numbers don't have a greatest common factor. However, they all have at least one A that I could take away, and they all have at least one B. So I am going to divide by AB, and then an AB comes out in front of parentheses. And so then the 3 doesn't have anything to cancel with, so the 3 stays in parentheses. But the A's are going to cancel 1 for 1, so those are going to cancel out. And then the B's, I can cancel this B with 1 upstairs, so I end up with just a B left over. Then the -5 has nothing to cancel with, so I have a -5. And then this A is going to cancel with one of those, so this A cancels with one of those, so I end up with an A. And then the B's cancel 1 for 1. And then finally, this 8 has nothing to cancel with, so I have a +8. But then the A's cancel 1 for 1, and so do the B's. And then you're left with double checking and making sure, can I factor this trinomial? Well, it's not a quadratic, so you're not able to factor it. That's it. All right, so then the next section, I'm going to make just a little bit smaller so you can see what the words are asking you to do. It says, when factoring, always look for a blank first. Well, that should be GCF. So even if you can factor without taking out a GCF, you really must take out a GCF. So I think we will end up doing, I think we're just going to do 6 and 8. So we're going to look at 6 and 8 out of this section for right now, and actually we're going to end up doing 11 and 12 as well. But we'll start with 6 and 8. So let me blow this up really big. All right, so then for 6, there we go. So 6, if you recall our method, we are going to take 26 and we are going to factor 26 and add those factors to get 15. So whatever the sign is of the constant, that tells us whether we're adding or subtracting the factors of this constant. Whereas in number 8, because our constant is negative, we're going to subtract the factors of 72. So we're going to start off with our T-chart. So in our T-chart, on the left-hand side here is going to go my constant. So because my constant is 26, and, oops, I don't even know why I put a 24. What's up with that? So I got 26. And because my 26 is positive, that means I'm going to add the factors of 26. I am looking for my middle term of negative 15. The factors of 26 are 1 and 26. And you can use your divisibility rules to help you. You've got a calculator to help you. So those are the tools that are at your disposal. If I add 1 and 26, I get 27. And then the next factors after 1 is 2. 2 goes into 26 13 times. And if I add those, I do get 15, which is what I'm looking for. Now my 15 is negative, so 100% of the time the bigger of these two carries the same sign as this one, so 13 is bigger. So 13 gets the sign of negative. Then all you have to do is decide what's the sign of the 2. For the 2 to combine with the negative 13 to make a bigger number, negative 15, absolute value-wise, the 2 is going to have to be negative. So now that we have our signs, we can go ahead and put them in our binomials. So the w squared gets split into w and w here. And then over here, the minus 2 and the minus 13 are going to go here. So minus 2 and minus 13. And that's it, it's factored. Now you can check it. You can refoil the whole thing, but w times w is our w squared. And then our last terms, negative 2 and negative 13, do give you positive 26. You can also, find your inner and outer terms to double check. Do they give you negative 2 and negative 13? And they do. I'm just not going to take the time here and do that. All right, so then I want you to try number 8 on your own right here. So pause the video, go through this whole plan and see if you remember how to do it. Okay, so we're going to take 72, factor it. We're going to take the factors of 72 and subtract them to find negative 1. So in my T-chart, that is not the one I wanted. So in my T-chart, I'm going to take 72, which is negative. Because it's negative, we are subtracting. And I'm looking for the middle term of negative 1, because that's the number here in front of the n. So my factors of 72 would be 1 and 72. Subtracting gives me 71. 2 goes in there 36 times, giving me 34. Still not what I'm looking for. 3 goes into 72. 26 times, and that's going to give me 23. And then 4 goes into 72 18 times, and that gives me 14. 5 doesn't go into 72. 6 goes into 72 because 2 and 3 went in there. So 6 goes in there once, twice, so 12 times, and that gives me a 6, so we're getting closer. 7 does not divide into 72, and then 8 and 9 do indeed subtract to give you 1, so finally, there it is. Now the sign of my 1 is negative, so that means that the bigger of these two carries that sign, so 9 gets the sign of negative, and then 8 would have to be a positive to combine with a negative 9 to make negative 1. Now that we've found those, we can throw them in parentheses, so we get n, and then plus 8, and then n and minus 9. All right, so let's tack something onto this. If we look at number 12, this time we have something in front of the k squared, but remember that your very first question always should be, is there a greatest common factor? So because 2, 16, and 40 are all divisible by 2, the whole trinomial, it does have a greatest common factor, and that factor is 2. So we are going to factor out a 2 and bring that out in front of parentheses. So 2 divided by 2 is 1, so I end up with a k squared. Then negative 16 divided by 2 is negative 8k. And finally, negative 40 divided by 2 is negative 20. Okay, so then from here, you're just going to factor this trinomial just like we did in the last two examples. You're going to take the factors of 20, subtract them to find negative 8. So I'm going to set up a t-chart. The factors of 20, because 20 is negative, we are going to subtract and look for negative 8. So I have 1 and 20, subtract to give me 19, 2 and 10, subtract to give me 8, and so there it is. The sign of my 8 is negative. That means the bigger of the two carries that same sign, so the 10 is negative. The 2 is going to have to be positive to combine with negative 10 to make a negative 8. So then this 2 gets brought down, but this is now factored into two binomials, and so the k squared becomes k and k. And then what you have here, the plus 2 and the minus 10 go here. So plus 2 and minus 10. And so this is your full factoring. Now you try number 12 on your own. So pause the video, do the factoring, and come back and look at your answer. Okay, so if you look at all the numbers, 5, 25, and 30, they are all divisible by 5. So I'm going to factor a 5 out in front. And so 5 divided by 5 is going to give me z squared. Negative 25 divided by 5 is negative 5z. 30 divided by 5 is 6. So now all you have to do is factor this trinomial, but you have to be really careful. You've got to know whether you're adding or subtracting the factors of 6, because look at my factors of 6. I've got 1 and 6 and 2 and 3. If I don't know whether I'm adding or subtracting the factors of 6, I can get 5 two different ways. If I add these together, I get 5. And if I subtract these, I get 5. So I've got to know which is which. Well, remember, we determine whether we add or subtract by the sign in front of the constant. So because our constant is positive, that means we are going to add the factors of 6, and we are going to add them until we get the negative 5. So the 1 and 6 add to give me 7, but the 2 and the 3 add to give me 5. So these are the two that I want. My 5 is negative, so the bigger of the two carries that sign, and then the 2 will also have to be negative in order to combine to make a negative 5. So now the 5 gets brought down in front, and then you have your two binomials. Z squared becomes z and z, and then you have your minus 2 and your minus 3. And so that's it. All right, so on this page we have kind of, more of the same, except for now all of a sudden, if you look at 16, and we're going to do 16 and 18, get these bigger, give us some more room. Okay, so with 16, I still have something in front of the x squared, but now I can't get rid of it like I did in the previous two problems by dividing it out as a greatest common factor, because 5 and 2 and 12, they don't have anything in common. They don't have any variables in common. They don't have any numbers in common. So what are we going to do? So if you recall, I had taught you before that you needed to take the coefficient in front of, and let me move this down a little bit so I have room to write. You need to take the coefficient in front of the x squared term and multiply it to the constant. So 12 times negative 2. That's going to create a new trinomial. So we get x squared plus the 5x, but 12 times negative 2 is negative 24. So now I know how to factor this. So I'm going to take the factors of 24 and subtract them to get 5. So the factors of 24, and because 24 is negative, we are subtracting those factors, and we are looking for a positive 5. So 1 and 24 give me 23. 2 and 12 subtract to give me 10. 3 and 8 subtract to give me 5, and so there it is. My 5 is positive, so the bigger of the two gets that same sign. And so then the 3 is going to have to be negative in order to combine with the 8 to make a positive 5. And so I can put those in my parentheses. The x squared becomes x and x. And then you get your minus 3 and your plus 8. However, this time if you multiply x times x, you get x squared, which doesn't match with 12x squared. And if you multiply the outside terms, negative 3 and positive 8, you get negative 24, which doesn't match with the original constant. So it matches with this, but not with the original. So instead, you're going to have to reverse out what you multiplied here by dividing it back out into those two. So because we multiplied by 12, we get to reverse it out. Now here's the problem though. If you can reduce this fraction that you see here, you must reduce it before you pop anything up in front of this variable. So because I can reduce the 3 and the 12, 3 divides into 3, negative 1 times, 3 goes into 12 4 times. And then with the 8, 4 goes into both of those, so 4 goes into 8, positive 2 times, and 4 goes into 12, positive 3 times. So once you've reduced this fraction, now because 4 doesn't divide into 1, you're going to pop the 4 in front of the x but behind the parentheses. So it looks like 4x minus 1 times, and then you're going to pop this 3 in front of the x but inside the parentheses, so you get 3x and then plus the 2. So remember the 2 came from here, the minus 1 came from here, and then the 4 and the 3 popped up in front. And so then this ends up being your final factoring. And you can check it by looking at 4x times 3x is 12x squared, and now that matches. Negative 1 times positive 2 is negative 2. All right, so you pause the video and I want you to try 18. All right, so with 18, you kind of have something of everything that we've tried here. You do need to take out a greatest common factor first. I really don't want to multiply 16 times 54. It is a huge number. But instead, I can divide 16, 60, and 54 all by the same number. What might that be? Would it be 4? Would it be 2? Is it 6? What is it? So if you go through all of the realms of possibilities, it ends up being 2. So I'm going to divide each of these by 2. So this gets divided by 2. And if you don't divide out the 2 with the method that we use, your greatest common factor is going to get lost. And then you'll have the wrong factoring. So then 16 divided by 2 is 8m squared. 60 divided by 2 is 30m. 54 divided by 2 is minus 27. So then we are going to have to multiply 8 times 27. So 8 times 27 is 216. So we're going to take this and multiply it to this one. Now we still don't lose this GCF that's out in front. All we're doing is creating a new trinomial here. So we get m squared plus 30m. And then the 8 times the negative 27 is negative 216. So now we have to find the factors of 216 that subtract to give us 30. So you just have to have patience, go through your divisibility rules. So our 216 is negative. Because it's negative, we are going to subtract. And we are looking for a positive 30. So just be methodical. We're going to start with 1 in the number. If you add, we're going to subtract them. So if we subtract them, we get 215. The next number after 1 is 2. 2 goes into 216 108 times. So that gives us 106 when we subtract. 3 goes into 216 because 2 plus 1 is 3. 3 plus 6 is 9, and 9 is divisible by both 3 and 9. So is 216 then. So 3 goes in there 72 times, giving us 69. The next number 4 goes into 216 because 4 goes into 16. If 4 goes into 16, then it'll go into the whole number. So 4 goes in there 54 times, and so we end up with 50. 5 doesn't go in there because 216 does not end in 0 or 5. 6 goes in there because 2 and 3 went in there. So 6 goes in there 36 times, and lo and behold, when we subtract them, don't we get 30? And that's what I'm looking for. So I want these factors. My 30 is supposed to have a sign of plus, so the bigger of the two carries that sign. The 6 is going to have to be negative in order for the 6 and the 36 to combine and make 30. So now the 2 is going to stay out in front, but then I have 2 sets of parentheses. The m squared is going to change into m, and then we have minus 6 and plus 36. But remember that m times m does not give me 16m squared. So, and actually really I want to look to see, does m times m, does it give me what I have here? So m times m is m squared, so it's not 8m squared. And 6 times 36 certainly isn't 27. So if you recall, we are going to have to, since we multiplied here by 8, we're going to have to divide by 8 to back it out. So that's what we're going to do. Divide by 8. And then, of course, you have to reduce these fractions if you can, which we can. So with 6 and 8, 6 and 8 are both divisible by 2, so I get a negative 2 and a positive 4. With 36 and 8, they're both divisible by 4. So 4 goes into 36 9 times, and 4 goes into 8 twice. So then this number here is going to pop up in front of the m, but behind the parentheses, we still keep the 2. So then parentheses 4m minus 2, and then parentheses 2m plus 9. So again, where did this come from? This 2 came from the original GCF. Then this 4 popped in front, so I got 4m, and this minus 2 was left over. Here this 2 popped in front of the m, so we get 2m, and then that leaves us with 9 left over. So our final answer is right here. All right, so one more section. Difference of 2 squares. So the difference of 2 squares, it has a pattern, and these are the easiest ones of all to factor because they have this great pattern as long as you can recognize that you have the difference of 2 squares. So the pattern says that if you have 2 perfect squares and you're subtracting them, that they factor into, move this over a little bit, factors into the pattern of, clearly I did not take that off. Okay, so then we get, try one more time, then we get a plus b and a minus b. So we have this plus minus pattern going on here. And then the square root of a squared is a, so that's where the a's come from. And the square root of b squared is b, and that's where the b's come from. So as you look at a very simple question right here, x squared minus 4, x squared is a perfect square because any power that ends in an even number is a perfect square. And then 4 is a perfect square. Square root of 4 is 2. So as soon as you realize you have the difference of two perfect squares, you can immediately determine, oh, I have that factor pattern of a plus minus. So then we're going to take the square root of x squared, which is x, and that goes in the first slot. And then the square root of 4, which is 2, and that goes in the second slot. And there is your factoring. So you try 22. Pause the video, try 22. Okay, so once again we have the difference of two perfect squares. So as soon as we have that, boom. Well, let's erase that, try something different. How about this? Boom. I have a plus minus pattern. And so the square root of y squared is y. And the square root of 81 is 9. Then you have to make sure that this cannot be factored any further, because you might have the difference of two perfect squares again, and this is a perfect square, but y to the first is not. If it were y squared, then you could. Like for instance, if I had had y to the fourth minus 81. So y to the fourth is a perfect square because it's an even exponent. And so we would have this plus minus pattern. The square root of y to the fourth would be y squared and y squared. And the square root of 81 would be 9 and 9. And then here you would have the difference of two squares. You cannot factor the sum of two squares, but here you can. So you would still bring down this y squared plus 9, y squared plus 9. But then the y squared minus 9 would get broken into this plus minus pattern. And the square root of y squared would be y, and the square root of 9 would be 3. And then now you would be finally done. So that's a possibility, but let's see if I can erase this. Oh, I don't want all that. Try this. Nope. All right. And then make that, oh, there we go, good. Okay, so what I want you to do is I want you to try to factor this one and then factor this one. So pause the video and factor 24 and 26. All right, so with 24, you do have the difference of two perfect squares. So you have this plus minus pattern. And when you take the square root of m squared n squared, you get m n. And when you take the square root of 49, you get 7. So here, I don't have the difference of two perfect squares, so I can't factor that any further. And here, I can't factor the sum of anything there anyway, so this is the final factoring for 24. Then for 26, 26 is not even the difference of two perfect squares right now, because 2 and 32 are not perfect squares, and neither is b. But it does have a greatest common factor. The numbers have a 2 in common. And then at most I have two a's that I can factor out of both of them and take the same amount, and a b. So I'm going to factor out a 2a squared b out in front of parentheses. Now here I have the same thing divided by the same thing. So anything divided by itself is 1. So I get a 1 minus 32 divided by 2 is 16. And then two of these a's cancel with 2 upstairs, so you get a squared. And then the b's cancel 1 for 1. So now when you look in here, you have the difference of two perfect squares. 1 is actually a square root, perfect square. The square root of 1 is 1. 16 is a perfect square, and so is a squared. So this is going to get brought down. So 2a squared b. And then this one right here gets factored into that plus minus pattern. So the square root of 1 is 1, and the square root of 16a squared is 4a. Now we would have had the difference of two squares here, My A's look really terrible. That's an A, and that's an A. Okay, so we would have had the difference of two perfect squares here because 1 is a perfect square, 4 is a perfect square, but A is not a perfect square. So we are done. That is the full factoring. So there is a quick review of all of our methods of factoring. So now go practice your homework.